Thank you for attending today's Pivotal webcast. Before we begin, a few housekeeping items. At the bottom of your audience console are application widgets that you can use and resize, including Q&A, resources, help, and media. Your audio is being streamed through your computer and speakers. You can expand your slide area by clicking on the Maximize icon on the top right or bottom right corners. If you have any technical difficulty, please click on the Help widget at the bottom of the console. We encourage you to ask questions throughout the webcast using the Q&A component. Your questions will be answered during the session via Q&A component or following the webinar. To see responses for yours and other participant questions, click on the Refresh button throughout the event. Enjoy today's presentation with Oliver Gierke. Oliver?
Yeah, welcome everyone. Thanks for the introduction, Amy. I'm about to start my screen share. We should be good to go. Again, welcome to this session on what's new in Spring Data. My name is Oliver Gierke. I'm working as the Spring Data project lead at Pivotal and effectively lead the development we're working with a team of 4 people on all of the data modules. So what is this webinar going to be about? So the Spring Data module, or the Spring Data project, is actually an umbrella project consisting of a variety of modules that basically provide data access for different data stores, relational and non-relational. And we ship a so-called release train, which is basically an orchestrated set of individual module versions that are known to work together. And once a year we have our annual Spring One conference, and we usually do a kind of roundup of what's new in the latest releases. And this is basically a recap of that, and we will present you with some new features that are available in the latest versions. I'll be showing you quite a lot of code. Yeah, go ahead.
Oliver, would you go ahead and share your screen?
It says live streaming is in progress, but I can retry.
There we go.
Does that work now? Does that work? All right.
Yep, looks
so
good.
We'll
I see your code for a slide. You're good.
Thanks, Peter. So you see a lot of code today. There are like dedicated demos for the features that I show you today. So we curated them so that you find them more easily in a dedicated repository. It's actually over here in the what's new in Spring Data. If you just Google for GitHub and what's new in Spring Data, you will find that. It includes a few more examples than I'll be able to show you today, because we had 90 minutes in the original demo. But yeah, just feel free to play with those. And there's a more, let's say, more global or more sophisticated example repo that has examples for different store modules as well. So if you want to play with all the stuff and a lot of more stuff than I'll be able to show you today, then feel free to go ahead with those. I already mentioned that we ship so-called release trains, and that their primary purpose is to give you a dedicated set of modules working together. They also, or the release trains also, allow us to control or define when we upgrade to certain third-party dependencies. As you can probably imagine, an umbrella project like Spring Data integrating with different data stores, we have to deal with a lot of different dependency lifecycles. So Mongo upgrading their drivers from time to time, and new JPA providers entering the scene, and what have you. So we use those release trains for dependency upgrades. And the latest ones, or the latest one actually, is Gosling. Currently we name them after like computer scientists, and Fowler was the one before that. And I'll give you an introduction into the features introduced in those release trains. As I said, dependencies. The most crucial dependency actually is the one that, or the Spring Framework version that we depend on. And there has been some history. So we had Dijkstra in 2014 on Spring 3.2, Evans on introducing or upgrading to 4.0 basically, Fowler staying on 4.0, and Gosling moving to Spring 4.1. The pattern that you might realize here is that we basically try to stay on the last but one, or require the last but one Spring Framework generation as minimum dependency. So like with Gosling, for example, in September 2015, actually Spring Framework 4.2 was released, but we stay on 4.1 to not force anyone, especially like JPA shops that use Spring Data JPA, are a bit more conservative in terms of their Spring upgrades, and we don't actually want to force someone into a Spring Framework upgrade necessarily. So as soon as Spring 4.3 will come out, we will lift our framework dependency to 4.2 basically. Yeah. All right. So the next release train about to be released is going to be Hopper in like March. There's the first milestone coming next week or the week after. It will also be Spring Framework 4.1 based, and I have an introduction or a tiny outlook into what's coming and shipping with that release in the end of the presentation. All right, so what did we do for Gosling? We upgraded the framework baseline to 4.1, as I've just like went into detail with. There's also like other third-party dependency upgrades like Jackson 2.6 upgrade and the Guava one. These are minimum requirements, like for using Gosling. We also added support for Hibernate 5 because it's been quite a significant release in late autumn last year, and make sure that the Mongo module works with the 3.0 driver. We basically had to do some adaptations to our code base to make sure it actually works with it, because they of course use the major release to prune some APIs and stuff like that. To start things off, I'd like to introduce you to a concept that we call BOM-POM, which not only sounds funny, but is also incredibly helpful in case you're not working with Spring Boot. As I mentioned, we name our release trains after these computer scientists, and that allows us to allow you basically to refer to a dedicated version of some Spring Data module by just referring to the name. Oh, that's the wrong POM. Excuse me. I skipped the introduction because you're probably already aware of the way of what Spring Data is to some degree. So what you have here is a plain Maven project. It has these two BOM-POMs declared, one for Spring Framework and one for the Spring Data release train artifact, and it refers to a property, the spring-data.version, and that's set to Fowler SR2, right? And that's just a logical name. We have, like, for each release train, there's an M1, an RC1, a release version, and then we start with service releases 1, 2, 3, what have you, which are basically the bug fix releases. And as you can see on the left side here, if I zoom in here, we get Spring Data REST in 2.3.2, we get Spring Data MongoDB in 1.7.2, and we get Spring Data Commons in 1.10.2, right? So it's kind of a diverse set of versions, which you probably have to, or would have to, remember and configure your Maven project correctly if that BOM-POM didn't exist. So let me just like switch from the Fowler release train to the Gosling release train, so basically upgrade to the latest one, and just save that BOM, and then the Maven plugin in Eclipse here, or IntelliJ, or whatever you use, will just upgrade to Spring Data REST 2.4. It upgrades to Spring Data MongoDB 1.8 and Spring Data Commons 1.11. So it's basically simplifying the finding the curated set of dependencies that are required in case you're not using Spring Boot, because Spring Boot already ships that for you. But yeah, in case you're stuck with a non-Spring Boot project, or just have to maintain a piece of software that's just not happening to use Spring Boot. Right. You can find more information on that in the reference documentation, but yeah, that's basically it. Okay, so we've seen that. Let's start with Spring Data Commons. It's usually the module that I talk most about in such presentations, just because it acts as the foundation for all the store modules, and that means that all the features that we introduce there are rippling down into the store module, so that features we introduce there can be easily picked up by the store modules, or in some cases don't even need any additional integration in the store module at all. And let's start with the enhanced Java 8 support. What we have there is actually threefold. It's first and foremost, it's support for JSR 310 date time types. As you can see in that example here, it's using local date time, like to capture the creation and modification date of Spring Data. And this is a JPA project, and by default, most JPA providers unfortunately don't or can't really deal with these types, just because like JPA 2.1 was released before Java 8, and thus there's no requirement for those implementations to support these types out of the box. Hibernate 5 fortunately does already, and I'm pretty sure the Eclipse link reference implementation does in the meantime. But in case you're still on a Hibernate Hibernate 4 version, or use let's say Eclipse link 2.6 or something, that support is not given out of the box. Fortunately, there's APIs to tweak or to introduce that, and we basically do so by providing you with these JSR 310 JPA converters, which you either register as a persistent class in your persistence XML of your on plain Hibernate on plain JPA, or just point your entity scan annotation in a Spring Boot application to it, and it will automatically register the necessary converters for those properties to be able to be persisted. Right? That's basically it. That's available for Mongo and JPA in this case. We've had support for optionals as repository return types for quite a while. Traditionally, when optional wasn't available, there was null return for in case the query doesn't or didn't even yield a result. We support both the JDK 8 one as well as Google Guava optionals. So that's been in place for quite a while already. And an interesting new feature that we actually introduced on top of Spring 4.2, so you will need Spring 4.2 to use that, is the support for asynchronous method invocations using a completable future. So as you can see here, we define the method return type to be completable future and list customer, and that allows us to actually call the method and then not really wait for the result, but let it be asynchronously executed, and define using a lambda here to define what's supposed to happen when the call actually returns, right? So that's not something that Spring Data actually does. It's just like Java 8 APIs, completable future. What Spring Data introduces here and builds on top of the Spring framework is the asynchronous execution and the wrapping of the result into a completable future. But yeah, that's the feature part here, that we recognize the return type and like basically just make it work. That's here, and it gives you kind of nice way of delaying the execution of queries and then defining what to do with that. So you can sort of tap your toes into. I'm not going to argue that's reactive programming, but in that kind of style of async operations here. Right. So a final thing that I'd like to show you briefly, and also actually eventually end up executing some code, is the support for streams here. But I'll just show you the MongoDB variant of that, because it actually shows the difference in execution modes a little bit better than the JPA one. So by default, we've so far supported returning lists of objects or iterables, and most store APIs return a list, right? So whenever you say list or call find all here, the store will return a cursor, and then we'll internally iterate over it, map all the documents back onto a person object, and then create a list. So that means we have to read all the data into memory in the first place. With a stream, it's different, because we can just wrap the cursor into a stream, so that actually the terminating operation on the stream, which in this case here is the for each, will trigger reading the data, and that creates a different kind of query execution mode, and you'll see that in a bit when I execute that. As you can see here, these the individual items are basically read one by one, and the second item is read and converted after I've done the system out print line, right? That's basically the output of the system out print line. And the list case, if I had returned a list, I basically would have seen the after load, after convert output first, and then 3 system out print line outputs, and you see that it's basically kind of intertwined operations, and the person objects are mapped on the fly when the stream is actually consumed. That's pretty easy to implement with MongoDB, because we can just use the cursor. In the JPA case, we go ahead and use provider-specific API that basically we detect your persistence provider, and then instead of calling getResultList on the query, we rather use persistence provider-specific API to stream the results back to you. That's the story here for Java 8. All right. A tiny thing to mention, kind of significant in case you actually extend the functionality of Spring Data. I don't actually have going to show the example here, because there's nothing really fancy to look at. But previously, extending all Spring Data repositories has required quite some effort in terms of the code you had to write. You had to write your custom implementation class. You had to register a custom factory and factory bean, and the latter 2 parts are actually gone in Spring Data Gosling. So you can just go ahead and write your custom repository base class and register that with the infrastructure, and the need for the factory and factory bean implementations are gone, so that in the best case you can just throw away some of the code you previously had to write. And the great thing about deleted code is that it doesn't contain bugs, and deleting code is fun anyway. So just simplification in here in the extension mechanisms. The next thing I'd like to go into is the topic of web projections, or the concept of projections in the first place. It has primarily been a topic in the Spring Data REST module, but there also is quite a bit of support, or we move that support into Spring Data Commons and make that available with a plain Spring MVC application. So what you actually get is an interface or a component that you can just auto-wire into your Spring MVC controller that's called a projection factory, and it allows you to take either a domain type or domain instance or a map basically, and create a projecting proxy that is fronted by an interface that you define. Right? So we take the users here, and we have a usernames only, and that method just exposes the username of the user property. It works by you define accessor methods that can either be just like plain copies of the one on the backing bean, or use add value to actually compute an invocation result and the target being available here. You can also do more fancy stuff with like accessing Spring Beans by name and call methods on it, my method, and then handing over the target to that method, and basically enrich your objects with additional method calls in this case. Let me just like undo it, just to give you a rough idea of what you can do with that. And the interesting thing is that you can just like create instances of that usernames only interface here by using the projection factory. I'm using it here by in a lambda of a new method that we introduced in Spring Data Commons as well. So this thing here is returning a page of users, and then we define we want that page of users actually projected onto usernames, and then want to get back the list of username only objects, right? So we basically map that thing. That's the reading side of things. It will come in handy in a new feature that we propose, or that we're gonna ship with Hopper, but I go into that later on. There's also like the inverted kind of usage. So in this case, we create a response with those projections. You can also use that projection factory, and in this case even transparently use it, because you're not really using the factory explicitly, but just to capture request data. We've added support that if you just like declare that interface as a method parameter for your Spring MVC controller, like you see that user form, where is it? It defines 3 methods saying get username, get password, get repeated password, and Spring MVC will basically bind the request parameter or the request parameters of that interface to a map, and then back the proxy for that interface with the map, so that you can access the username property. It's kind of a like slightly less cumbersome to create variant of a DTO that you might introduce, or form backing object, but you can just like declare the getters for them and don't need to provide any setters and fields and what have you. So that will just work out of the box with a method that takes an interface of user form to capture incoming request data, right? So you can just like use the instance and call methods on it and what have you. All right. Yeah, I basically covered all of this. If the APIs like let you work with either just a plain Java bean as the target object for the projection, or a simple map with the keys being the properties to access. Another great area of enhancements in especially the Gosling release train is the Query DSL web support. For those of you who are not aware of Query DSL, it's a tiny library that we integrate with that allows you to write predicates or create predicates using a Fluent API in a type-safe way. So it's sort of like the Criteria API in JPA, but with a slightly more comfortable API, and that's probably even the bigger feature here, not restricted to JPA, right? And we got quite a few requests that were asking for whether we could actually provide some integration into Spring MVC again that would automatically, from the request parameters that you provide, create a predicate. So that's what we built and shipped with Gosling. Let me just run that application here. Where is it? Example application. Run this thing. And what this application is, it's basically just a tiny form, a couple of users in a database, and a search form for that, right? So you just see the results here. Well, let's wait for the application. You see the results here, and I can now go ahead and say query for the first name, and I find all the Walters, and you see that the request is actually just like submitting get parameters, right? So that's pretty easy here. So how does that actually work on the MVC level? The controller is we actually again created integration with MVC by just like tweaking some bits that a query DSL predicate can be a Spring MVC request parameter, and we also have means to define which type we want to bind the request parameters for. So by configuring that user over there on the left in that annotation, we actually create or we define that we want to grab request parameters that map properties of the user class and then create a predicate. And by default, we just do an equals comparison for all of the request parameters, but you can customize and define those parameters by creating a so-called query DSL binder customizer, which we by accident, quote unquote, implement with the query DSL repository. So you get some kind of a callback interface where you define or you have different ways of defining the bindings. You can either refer to a dedicated property. As you see here, we define for the first name property, we want to do an equals binding. And that basically results in, if I go back to the application and search for just W, it's not going to find anything. Let me try that. Because it like matches on strict equality here. If I go to last name, and just pipe in W here, you will see that it returns results that match, that basically just contain a W, right? So no matter whether it's a capital W or whether it's a lowercase w, results are found. And the reason for that is that there's a more general type-based binding here that binds, as you can see in the back, that binds every string property to a contains ignore case clause, right? And finally, we just exclude the user password property from being able to be bound in the first place, right? So that's a pretty interesting feature, I think, because it just like takes away the burden of like mapping those requests yourself, and you just get the full flexibility in the way you bind things, and all you need to basically do is just register a predicate as the method parameter here, and to get the predicate, and then eventually forward it to the repository find all call, which you can see below here. Give me a second. Where is it? It should be down there. Yeah. All right. That's the query DSL web support. Let's go back to the slides and start with Spring Data JPA. Get into the store modules a bit. There is quite sophisticated new support for the Spring for JPA 2.1 support, which is twofold basically. It's we have two major areas of features here. One is the ad hoc entity graphs. Give me a second. Let's find those. Entity graphs are basically fetch graphs, or defining which parts of the entity you want to return for a query. And the upper method here, the find one by ID, is referring to an entity graph that's defined on the product class. So it's using the JPA. Give me a second. It's using the JPA means to define such entity graphs, and over here, and the repository actually just refers to the one that's supposed to be used, right? Product with tags. That definition of entity graphs can become quite cumbersome, especially if it's just like basically a whitelisting that you want to do, like return 3 of the 10 attributes. And we introduced with Gosling, we introduced the ability to define an ad hoc entity graph directly on the query method. So you can just list the properties that you want to read, and you'd get those. That's the interesting bit here. And there's stored procedure support. So that was introduced in Fowler already. So we have an add procedure annotation that let me look it up. That will allow you to either define the name of the stored procedure that you want to execute, or completely derive it from the method name again. So in the case of the lower method, it's going to be user dot +1 in out, which would be executed. So it's an equivalent to add query basically, and but executing stored procedures. Right. There's a couple of other improvements that we made. So support for the cursor references. We upgraded to Eclipse Link 2.6 as minimum dependency, and assured compatibility with Hibernate 5. There wasn't too much to do with on our side. We just wanted to make sure we work on Hibernate 5. So in case you want to be sure it works, use the Gosling release train. I mentioned the attribute converters, and there's also a configuration option, a new one, that allows you to disable the default transactions, which we, as the name suggests, apply because JPA needs transactions for persisting entities by default, but that might run or bring you into a situation or uncomfortable situation in case you're using extended entity managers and what have you. So that can be switched off in either the XML namespace or the entity manager, the add enable JPA repositories annotation. Spring Data MongoDB has seen or has gotten a feature introduced that we actually had available in Spring Data JPA for quite a while already, and the feature basically is being able to use Spring security expressions in query expressions. So there is an extension point in core Spring Framework that allows third-party libraries to register spell functions, Spring Expression Language functions, in their to be used in a query definition. And Spring Security, the most recent version 4.0, ships such an extension, and is automatically registered in case it's on the class path, so that you can use those expressions like has role or has permission in your query methods, right? So it's not something really tied to Spring Security. Spring Security is just the first third-party library that I know. I mean, it's not really third-party, but library that makes use of that. But you could also go ahead and just like extend that and provide your own Spring Security expressions, which allows you to customize building the queries here. That's basically it. It's been available in JPA for quite a while already, but we moved that into Spring Data MongoDB as well. I already showed you the Java 8 bits and pieces, like the stream execution, because that's the most important stuff to show here. To summarize the changes in Spring Data MongoDB for Gosling is the evaluation context provider integration. That's what I just mentioned. Also, MongoDB 3.0 Java driver compatibility is in Gosling mostly. We keep track of the ongoing development efforts there. There's been some tiny glitches with Mongo 3.2 because they removed or introduced some incompatible changes in some corner cases. Nothing really problematic, but we had to adapt those, and there's some fixes coming in the next service releases for Gosling, and of course in Hopper. There's support for calling JavaScript functions through our APIs, Mongo template APIs. Basically execute JavaScript functions on the fly or register them in the server for later executions. That's pretty easy, and support for the new GeoJSON format. It's a kind of slightly different format to represent geometric shapes in MongoDB. That stuff was coming with 3.0 if I remember correctly as well. All right, that's it for the major store modules. Let's move on to Spring Data REST. It's a bit of an odd one out module because it's not a store implementation, but actually builds on top of the other store modules and analyzes your domain model and your repositories to expose HTTP resources for your domain model, so that you can trigger state transitions on it. And there's one feature that we've been asked for quite a bit, and that's whether we could expose the optimistic concurrency control means that the stores provide in HTTP compliant ways, right? So what do I mean with that? Both Spring Data, let's say the MongoDB module, and JPA provide means to capture or to support optimistic locking through an add version annotation. Spring Data also has some means to just like record the modification dates of entities when they are persisted, and you have some annotation means to declare properties in your domain model. The thing is that like when you expose those types via HTTP, the protocol actually has dedicated means for those, right? There's a last modified header, an HTTP response header that expresses that, and also for the kind of object state, HTTP has a so-called e-tag header, which is usually some kind of hash over the representation. But with the version property in place, we can just go ahead and use that as the e-tag, and that's what Spring Data actually does out of the box. Spring Data REST does out of the box since version 2.4. So there's just a test case here that proves that it's working. So we access the customers here, or an individual customer basically, and we make sure that the e-tag and last modified headers are present. And then we execute what's called the conditional request by adding the if not match header and using the e-tag. So that's basically saying, dear server, please give me a representation unless or only do so if the representation does not match that e-tag. So it's basically expressing, give me a representation in case it has changed since that very e-tag. And we make sure that we get a is not modified header, which is 3 or 4 basically, so that signals the client that nothing has changed, right? In case something has changed, we would just get a 200 with a new response, but it basically allows the server to omit the response body and save network bandwidth. The same works with the last modified header. It's just like using the date and not the e-tag. That's just a different flavor here. That's support we have in there out of the box in Spring Data REST. It also supports and has supported in previous versions the notion of conditional put requests. So you can use the e-tags to say, to like turn the request around and say, dear server, please update the resource only if it's still in that particular state, right? So that you don't accidentally override changes that have happened on the server here. That's basically the out-of-the-box support. Excuse me, the out-of-the-box support that we provide here. Another significant enhancement to Spring Data REST is the Hell browser and our custom tweaks that we make to it. What's the Hell browser? Hell is a JSON media type. It's not a JSON media type. It's a hypermedia media type, and it comes in a JSON and an XML flavor, and its primary purpose is to enable hypermedia links in JSON, which JSON doesn't know out of the box. And Spring Data REST is using that media type to render its resources, right? So with that in place, we can, let me start the application here. It's just a tiny sample application that, where's my browser? Over here. Did I kill the other one correctly? Try localhost 8080. Just a sample application that uses a MongoDB and does some location search, produces some results, and then uses the REST API to call or to display the location of these stores on a Google Maps map. That's pretty easy. If we go to if we take a curl browser and query the endpoint, which is 8080/API, I moved it to that thing. If we go here, then you see, okay, there's some endpoints generated that expose the stores, and if we just follow the stores link, we see the stores being published, right? So you could like use curl or what have you instead. To explore the API, it's kind of nice to actually have some HTML front end to see that or play with it. And the Hell browser is some kind of a JavaScript application that you can easily deploy with your application by just adding a new dependency to your project. It's basically like taking or adding that the Spring Data REST Hell browser to your POM. Let me show you that in a second. And what that then does is it provides you with an HTML JavaScript application. That's not something we built. That's actually built by the inventor of Hell, Mike Kelly. We just like packaged it up so that's easily consumable from a Java project. And it understands the nature of Hell and the way that links look like, and presents you with, in the lower left here, it can extract the links from the response and basically provides you some UI to play with the API and trigger requests. As you can see here, I can fill out the request the URI template with some properties. But it fundamentally knows about Hell, it knows about URI templates, and for all of the input stuff, it provides you with a generic text field, sort of prepared with some JSON templates. And what Spring Data REST actually knows or exposes is some metadata that, like a JSON schema plus JSON. Let me go there. Stores, that is. That exposes the structure of the object and returns some meta information. So what we've done is that we tweaked the Hell browser slightly, that for a non-GET request, you're not actually presented with an arbitrary input field where you have to type in your JSON, but you actually get a decent form to type in some data. That's fed by the JSON schema that we just exposed, right? So the Hell browser sort of discovers the JSON schema and then hands the schema forward to a tiny JavaScript library that produces a form, and we can go ahead and now fill out the form and actually make a request and then get that sent to the server and basically create new stores with it. So kind of handy to just ship with your application, probably a staging environment or some kind of dev environment where you want to let developers play with your API. And it's also kind of easy to integrate other API documentation that you might have generated with Spring REST bugs or what have you. That's kind of decent. Not Spring REST bugs, Spring REST docs. Sorry for that. That can be integrated into the Hell browser too, but that's the Spring Data parts basically that we ship here. There is a lot of other internal improvements here. Repository entity links has seen some overhaul. We revamped this JSON schema support. We have support for automatic translation, internationalization of enum values and link titles. So with using resource bundles, which makes it kind of convenient, especially if you have clients that just reuse or use the names of the links as is. That's pretty much it for Spring Data REST. There's a new kit around the block in the Gosling release train. That's the Spring Data Key Value module. It's basically an implementation of the repository abstraction based on top of a Java util map. That allows us to provide a very low-level implementation of that you can use for testing purposes to just like pipe data into a map and read data from it. We've implemented the query derivation, so executing queries on these map-backed repositories using the Spring expression language. So a find by username method would be translated into a spell expression that's then evaluated on the collection of map values, basically. So it's kind of handy for testing purposes and to play with. The actually more important feature here is that it provides SPIs for other key value stores to leverage because they can just plug in their own store implementations. So let's say take Hazelcast, take take Cassandra or Redis or Aerospike or any other key value store. Cassandra is not one of them. Sorry, that just slipped through. Gemfire, for example. And with the minimal amount of code, just integrate with that and basically replace the dump query derivation via spell with store-specific APIs that make sure that use more optimized ways to query the data and maybe even reach out into a distributed map or what have you. So a lot of infrastructure here, but nice thing to play with or look into if you want to just like create tests on with simple repositories. All right, to round things off, to give you a quick outlook on what we're going to ship with Hopper with the next release train. We're looking into query by example. There is working prototypes for MongoDB and JPA. I know a lot of JPA implementations provide something like this, but they all differ in feature set, and we want to extend that onto MongoDB and other stores as well. So we have that in place and looking into whether we ship that with M1 already or with the release candidate. There's quite an important one which is projections on query methods. So basically being able to use the projections feature I showed in the Spring Data Commons section of the webinar on repositories directly, so that you can massage the query results into those projections, and in inspecting the projections even optimize the query in the first place. So if you just want to return 3 of the properties of a domain object, we not have to query the entire object, but only 3 columns of it, of something like that. Ongoing work there, sort of finished, about to be merged with the milestone 1 as well. Same applies to the Redis to object to hash mapping. So it's basically a repository implementation on top of Redis. Christoph, the guy working on it, has put a lot of effort into creating the required indices to make that happen and to query Redis objects, Redis stored objects effectively. And it's going to come with milestone 1 as well. There's a major upgrade in the Query DSL support, so we moved to Query DSL 4. There's some breaking changes in terms of like moved classes into new packages and new artifact IDs. So we take a dedicated step to bump everything up to Query DSL 4.0. That's in place already and can be used in the snapshots. And we're going to see some major dependency upgrades. So the Neo4j guys did a complete rewrite of their Spring Data module in 4.0 in, I think, autumn last year already. We're going to reintegrate the 4.1 version then into the release train. Same goes for Couchbase with 2.0 about to be shipped anytime soon. We're probably going to have Couchbase 2.1 in the release train then. and the Solar 2.0 modules is going to bump the Solar version to 5.0. So that's coming here as well. With that, I'd like to basically open the feedback channel here and ask for questions that might have popped up. And Peter, were there any on the?
Yeah, not too many this time, just two. This was early on, about 20 minutes after you started, and the question is, yeah, I see in the demo you have a customized repository method to return stream. Could this be native to the repository, similar to Finder methods, something like find ... with stream, should, and obviously should return a stream?
I'm not quite getting what the question is, except what we actually ship. So let me go ahead and try to reopen that in the Mongo space. So we have this is just a query. It's basically just mimicking find all, that very method here, and it just returns a stream. So you'd usually go ahead and probably have a. Let me see if the Java 8 example above has it. So you have, it's find all, but you can just have here, and this is it. This is an example here. The queries just work as expected. So you can go ahead and add query to that method and execute arbitrary methods, or use method query derivation from the method name here. What we do is basically we tweak the execution into either a cursor-based stream on the MongoDB side, or using native persistence provider APIs to execute the streams later on. So that's actually executed as a stream. That's not only calling list.stream, right? So because that wouldn't make any sense whatsoever. I mean, not any sense, but that wouldn't bring or any of the benefits that streams bring with them. So that's here. And maybe to add a note on some more advanced topics like the reactive efforts coming in Spring Framework 5. We're working closely with the Spring team on looking into the more reactive drivers or async drivers that, let's say, MongoDB and Couchbase actually offer, and there will be support for even more reactive data access coming in a major Spring Data revamp at the end of the year, basically around the same time as the Spring Framework 5 milestones will start to appear. So we're working with those guys and to make data access even more reactive in this case.
Awesome, thank you. All right, and then just one more question, I think. Would Spring Data REST be able to expand or contract, like hide, an object's properties on the fly? Example, I would like to see only some properties of customers when I do a get.
Well, that's a bit of yeah, you have to go into details with that. There's a few ways to skin the cat here. If those properties are should be part of put and post requests as well. So for creation, if they are relevant for creation, you still need to have them in the representation. So you can't just JSON ignore them. And we have a dedicated feature for that called projections. So you can craft these interfaces that I've shown in the common space, and then register them as a projection for a certain domain type, and then explicitly request those. The other option is using just at JSON ignore if you want to completely remove those properties from being part of the requests and responses, then just add JSON ignore them. That's just fine. It will work just fine as well.
Excellent. All right. Well, I don't. Any other questions? If you do have any, folks, now's the time. Excuse me. And just want to let you know, we do post the recording of this. This is being recorded, and we post it to spring.io/video. Again, spring.io/video. And that'll take you right over to the Spring YouTube channel. And if you subscribe there, you will get a notification when the video replay is being posted. Otherwise, you can just go look for the webinar replays playlist, and it'll be there. The other place that it gets posted is to the Spring blog, which is located at spring.io/blog. And again, if you'd like a notification, you can just subscribe to the Atom feed there. And then not only will you get a notification about the replay going live, but you'll get all the amazing blog content that comes out from the Spring engineering team, which I highly recommend. Also, if you like, we have another webinar this Thursday from Kenny Bastani, who's going to be doing a seminar on creating a PageRank analytics platform using Spring Boot microservices. And he has a companion article and sample code and stuff like that, which is really awesome. So he's turning that into a webinar. And I think if you're into the microservice idea and kind of curious about what we're doing there, that would be a great one to attend. Oh, and we got one more question that just popped in. Hold on one second, Oliver. Here we go. So REST repositories output contains data inside an underscore embedded tag. Is there a way to have it be flat JSON?
Well, complicated question again. We use HAL as the hypermedia type of choice, basically, and that defines the entire response having to be a JSON document. So the way that HAL represents collections, and that's what you've seen, is that it defines this so-called underscore embedded property, which then again has keyed by relation name the possibility to have one or more items below that. When you access an item resource like a single customer or something, that underscore embedded is not going to appear. So for individual objects, that's there's no underscore embedded, except it's like preview objects into related instances or into related resources. The thing is that by using that type, you can basically write a client that understands that media type and that media type only, and you can write client logic that extracts data from it, and it doesn't have to basically it doesn't know about your application, but can access data just by knowing that very media type. So there's a legacy format that we had introduced or started in 1.0 versions with Spring Data REST, but it's not what we recommend. So for collections, the underscore embedded thing is what we like, or what you have to work with right now. And I'd argue that's a decent thing to do, because you could just like take an arbitrary HAL library on the client, or use our libraries like with Traversin or REST template to just like get the stuff mapped back into what we call resource classes. It's basically representation model classes available from Spring HATUS. So when you're using those on the client or using a HAL library on the client, that underscore embedded should actually be transparent to you. So it's not really visible to clients then. But yeah, because Spring Data REST heavily uses hypermedia to let the client discover the API, to represent relations to related entities and stuff like that, there's basically no way around to create representations without these kind of links, and thus you need a hypermedia-based representation type, and then you're back into the choice of what we want, and our first choice is HAL here.
Excellent. Thanks again, Oliver. Okay, so I think that wraps up the questions. Wow, and and a few thank yous coming in from folks. So
yeah, very welcome, guys.
Yeah, once again, nice job, Oliver. Thank you. That was really thorough. So in case you haven't discovered it yet, folks, if you look in the resources section of the On24 console, you'll find a bunch of follow-up links, including the GitHub URL, for all of our source code for this presentation. Obviously, when we post the replays, we also link to the slides on SlideShare and things like that. So there's a bunch of great and very helpful related resources in that resources tab, and they are clickable. So before you sign off from the webinar, you might want to just take a quick peek down there and see, what it is that you might want to grab or copy and paste for yourself, or just open a browser tab. So with that, I think I just want to mention again. This Thursday, Kenny Bastani from the Spring team is going to be talking about creating a PageRank analytics engine with Spring Boot microservices. So again, there's always 2 sessions. And then just a minor housekeeping note, if you're just one of those people that really needs HTTP downloads, just bear in mind that we really sort of encourage Maven downloads, and we don't make it easy to download HTTP on the website, but you can get HTTP downloads. So if you're stuck behind a firewall or proxy server on a military network or something like that, you can get those from the Artifactory server at repo.spring.io, R-E-P-O, repo.spring.io. If for some reason you are in desperate need of an HTTP download for Spring data bits and binaries, but Maven is definitely the preferred way. All right. Well, actually. Oliver, it looks like maybe one last question came in. Since it's only 2 after, maybe we can squeak it in and then sign off. How does that sound?
Of course, go ahead.
Cool. Okay. Not sure who it comes from, but he said the question is there a way to have query DSL return more than the ID after an insert, like the whole object?
I don't think it is. That's a pretty detailed question. I'd have to look into that, but I don't. I think it's just like triggering the inserts here. I mean, it sort of depends on which API you use. But taking a step back, when you insert stuff, you're not really using query DSL, right? You just like pipe the entity to entity manager persist, because it's more about querying. I mean, you might be referring to an update query, but I don't think that that's returning more than the actual ID of the row that was updated. I mean, in the worst case, you can just like hide that implementation stuff inside a Spring Data repository method that you implement yourself, execute the query, and then basically refresh the entity that you've handed in. That's what I'd recommend.
All right. Well, I think that just about wraps it up. No more last-minute questions, and wow, bang on time. Only 3 after. Amazing, Ollie. Thanks again. And did you want to say anything to the audience before we sign off? I think we're all set.
Just encourage everyone to give feedback, play with the samples. In case you find issues, don't hesitate to create tickets on Jira, or reach out on GitHub, or any way you like. Basically, we're really welcoming any kind of feedback that we get. And yeah, enjoy using the stuff.
Great. All right. Thanks, everyone. Appreciate your time, and have a wonderful day. Bye-bye.
Take care.